Okay, so part C on the forest defoliation, again, it asked you to determine how many egg masses existed if approximately 2/3 of the forest had been defoliated. So now all we're going to do is try to solve this equation. So how would you solve this equation?
You would multiply it by 3 plus 17, that way.
Yes, we would multiply by 3 plus 17 e to the negative 0.0625. So that's exactly what I've done right here. Multiplied both sides by 3 plus 17 e to the negative 0.0625x. You could distribute your 66.7, but couldn't you also just divide by 66.7? So that's the next thing that I did. I divided by 66.7. And then at that point, you would subtract your 3, divide by your 17, and now how do you solve? Use a natural log. Yep. So you're going to take the natural log of 1.5 divided by 17 and then divide it by 0.0625, and you get 38.868, which would give you 38,868 egg masses. Okay? Then part D asks you, and this is the part that you need to be able to translate words into calculus meaning. When it asks you to use calculus to estimate the value of x for which y is increasing most rapidly. If we're looking at how y is increasing, what calculus concept is that? The derivative, correct. And so then if it's asking you when is it increasing most rapidly, what that's asking you to do is find the maximum value of y prime. Okay, so that means I need to find the derivative of y. So to find the derivative of y, I would use quotient rule. Remember, you do denominator times derivative of the numerator, which is just a constant, so that's 0, minus 300, and then times the derivative of the denominator. Yeah, I need a times. Make sure you use that chain rule, so I ran out of room. Make sure you use that chain rule times the negative 0.0625 all over the denominator squared. So I'm just going to type this in my calculator now and find the maximum value. So all this just turns into 0. So my derivative formula is this function. Type it into your calculator and then find the maximum value. AP Board accepts using a calculator to find a maximum. That is something they allow you to do with your calculator, expect you to be able to do, and would be fine with you giving them this derivative and then saying the maximum value occurs when x is 27.75. Okay, for part C on the second question, at what rate is the fish population changing at the end of 1 month and at the end of 10 months? So again, we have this logistic growth model, and it tells us that T is measured in months. So when I ask you at what rate is the fish population changing, this is your population formula. So to find out the rate at which it's changing, you would need to find the derivative, which again is the exact same concept we just did for that other logistic growth model. And then just input 1 and input 10. Make sure you can handle the units here. Isn't the population changing over time? So that would be fish per month. So that turns out to be 113.5 fish per month and then 403.2 fish per month. And then again in part D, it's asking you the same thing. After how many months is the population increasing most rapidly? So again, that means you would find your derivative, which we've already done, and now find the maximum of that derivative. And that occurs at 14.72 months.